Here I am, I have a blank map open in ArcGIS Pro, and I want to use as my reference map for georeferencing just the base map that we see here. So I go back over here, and in the Module 2 data folder, you will see a file called shell map. And if I just open that up, this is a map, an old map from 1956 from Shell. They used to give it out at gas stations for people who were coming to Ottawa as tourists. Right now, it just has a column and row coordinate system. It has no georeferencing in it. So when I go back to ArcGIS Pro and I go to my Module 2 data folder, I find my shell map and I drag that in. And it will add that data to the map. So let's go see. Let's go have a look near Ottawa to see if it added it near Ottawa. Zooming in here and over here again. I don't see my shell map here anywhere. And that's because it's in a column and row coordinate system. And remember, in a column and row coordinate system, we have 0, 0 as the top leftmost cell. And where 0, 0 is found in this real world coordinate system is going to be at the prime meridian and the equator. So somewhere down here is where we're going to find our shell map being put. So I'm just going to zoom to it. I'll right click and say zoom to layer. And there it is. So it's off the coast of Africa. Zoom out quite far. You can't even notice it there. So when I brought my shell map in, because it has no georeference, ArcGIS Pro just puts it into the real world coordinate system as if the column and row coordinates were part of this real world coordinate system. So 0, 0 will be right here. And you can see that in my status bar at the bottom, that right here is 0 east, approximately right up in the corner somewhere here will be 0 east and 0 north. So to georeference this, I need to find common things that I see on this map here. And good things are things like street intersections in particular, ones that may not have changed since 1956, or physical features that have not changed since 1956. So I need to find those, and then I have to go all the way back to Ottawa. So I'll have to zoom out quite a far here again. And I'll go over here to Ottawa, and I'll have to find those same locations in this real-world coordinate system reference map, like we see right here for Ottawa. So that's going to be inconvenient because I'll have to keep going back to the equator and prime meridian to find a control point there, and then find the same point here on this map of Ottawa. Luckily, there's a way to have the shell map display in any area of the screen that you want. So let's say I just want to have the display, have the shell map moved here for display purposes. So it's not way down at the equator. That way I don't have to keep zooming way out and way in to find control points. To do that, I click on my imagery tab at the top. And the second button is Georeference. Once I'm in Georeference, the first thing I'm going to do is click off of this thing that says Auto Apply. It's on by default. We don't want that on. We click on it to turn it off. Then I click on Fit to Display. And it just brings the shell map up here to wherever my display is. If I move my display over here and I click Fit to Display, it just moves the picture over to the right to fill the display. And I might want to zoom in a bit more and maybe go over here and Fit to Display again. So I'm just trying to find a good fit visually here, just so I can see things on both the raster that needs to be georeferenced and the reference map over here. So let's have a look here to find some control points. So I'm going to use street intersections because they haven't really changed everywhere over time. So here, for example, is Sussex Street and Stanley. So that's one possible control point. And then I just have to find that same street intersection on the reference map. And that will be a full control point set. To do that, in the georeferencing toolbar, I click on the Add Control Points button. And when I bring my mouse over the map, you can see it changes to a crosshair. And the way we georeference is always from the source map without a coordinate system to the map with a coordinate system. So for example here, I'm going to click on the intersection of Sussex and Stanley. I click once and release my mouse button, and notice there's a line that's created. And now I'm going to zoom out just using my mouse button. I'm going to use my left arrow to just move over to the Ottawa region, and I'm going to now zoom in to Sussex and Stanley, right there, and I'll put a point. So that's one control point. Now I'll go back up to my toolbar, click on Map, and I'll click on the Explore button. I'll just double click on it to make sure it's working. And I'll zoom back out. I have one control point now at the corner, or at the intersection of Sussex and Stanley Avenue. And there's a green dot there, meaning that's the 2. And then over on the map, somewhere over here, I might zoom out a bit more to find everything. There's my map over here. I have the control point origin on the source there. You see the red crosshairs. So that's one up in this area. The next thing I'd like to do is find something in this region here. So I'm going to try and kind of get an X pattern going here in the control points. So one up here, maybe one over here as well. So here's a good one. So this is a Belvedere Crescent. I think that'll be one I'll be able to find easily. I'll put a dot in the center of that crescent, that dead end. So I'll go back to my Georeference tab, add control points, go and approximate the center of that feature as much as possible. I'll click once to put my from coordinate, and then I'll go over here to using my left mouse button again just to pan over, and that should be up here somewhere. I bet it's right there. There it is, Belvedere Crescent. So I'll just zoom in a bit more to get the middle of that really well, or approximately right there in the middle. Great. So now I have two control points. These are added to the control point table. So in the Georeference toolbar or tab, I'll click on control point table so I can actually see these two control points. There's 1 and 2. We have a source X column and a source Y column. And these are the column and row coordinates. In this case, the row coordinates, Y coordinates, are negative because they're going from 0 at the top downwards. Remember, the origin of the column and row system is in the top left corner of a raster. And so when we click on things within our map, they'll all have a negative column coordinate. Then we have X map, Y map, the corresponding real world coordinates for those column and row coordinates. And then we have a residual X and a residual Y and a total residual. And we'll talk about those later. Right now, they don't mean anything at all. They don't mean anything until we have really more than 6 control points. So for now, I'll just keep my control point table open at the bottom here. And again, I'm going to go back to my map. I'll double click on Explore here, and I'll zoom out, and I'll find some other region that I'd like to find a control. See, that actually made a control point. I didn't want that control point to be, see, it's not completed yet, so I'll just hit escape. And that sometimes happens with the tool. So I want to get a double click on my Explorer here, and hopefully that works now. Yeah, no, it's still not working. So it's still thinking it's making control points. So to fix that, I'll click back on my Georeference, add control points, and then click back on map, explore. There we go. So sometimes the buttons are a bit sticky, and it's just a buggy thing in ArcGIS that we have to deal with. So the control points, I can see I have one here and one here now. Now I want something in the middle, down in here. So let's have a look. So how about George and Cumberland Street? So that should be good. I'll be able to find that again, George and Cumberland. Or it could be King Edward and George, or York and Cumberland. Maybe I'll choose York and Cumberland. So I could click back on my Georeference tab, add control point. So I remember here it's York Street and Cumberland. So I put a from part of the control point. So this is the source X, source Y part of the control point. Then I'm going to zoom out here and use my left mouse button just to scroll over till I get my mouse around the region of the market. So there's York and Cumberland. This doesn't look like a good control point, because notice here that York Street is split now. It wasn't back in 1956 when the map was made. So I'm going to hit escape there. I'm going to try instead for Dalhousie in York. So I'll go back to my map, zoom back out, and I'll just use my right mouse button to pan over. And my down mouse button to pan downwards. So that one wasn't working out for us. Let's just see here. Pan over a bit more. So we said York and Dalhousie instead. So York and Dalhousie instead of Cumberland. So York and Dalhousie right there. Click back on my Georeference tab, add control point. Right here in the center, York and Dalhousie. And then again, using my mouse wheel to zoom out, left arrow to scroll. There's Dalhousie there, and York right there. There we go. Now we have 3 control points. Now that we have 3 control points, I'm going to go back here to my map tab, explore, make sure I click on that button, and I'm going to zoom out. And once we have 3 control points, there's enough information for an affine transformation to take place. And that will orient our map right here into the real world in approximately the true locations of where things should be. So I click back on my Georeferencing tab, and now I click on Auto Apply. And there we go. Already we have things fairly well matched at this scale of view. So at the scale of view we're looking at here, things look fairly well matched, and we just have 3 control points right now. We want more than 3, because we want to have that X-type pattern as much as possible. So I'm working on from this corner up here through down to here. We can't go right to the other corner of the map because it's just text. So I'm going to now look down here for something. So I zoom in. So here's some things like O'Connor and Waverly, perhaps, or Bank Street and Waverly. So I can't see both at the same time now, can I? But if I click on the Appearance tab, making sure that my shell map is still selected, click on the Appearance tab for this shell map, and I can click on this off and on button. So it turns them off and on every 500 milliseconds or half a second. So I'm looking again here for Bank and Waverly, and it's right here. So I'm going to zoom in a bit there to where Bank and Waverly should be. You can see the actual location is right there where my mouse is. And the location in the column and row system is right here where my mouse is. So I leave it flashing, click on my Georeferencing tab. Again, add control points. And now I'll click in the From region. Again, this is the column and row coordinate. And then I'll bring my mouse over to the actual location and click again. And that brings that over and lines that up better now. So I'll click back on my Appearance tab and I'll click off the flicker or flashing. Click on my Map tab, my Explore button again, and I'll just zoom out. See how our control points are looking now. You'll also notice now that we have 4 control points. We have more than 3, and so we have up here a root mean squared error of 6.38 meters. We can also see at the control point table down here the contribution of each of these to the residual. Because remember, the squares of the sum of these numbers and then the square root of that divided by 4, because there's 4 numbers here, gives us the root mean squared error up here, called the forward error. And it's 6.38 meters because we're working with a reference map that is in meters. It's in the Web Mercator projection. So I'm going to click on my Appearance tab again. Instead of flashing, I'm just going to make my raster half transparent. And this way I can kind of see how things are lining up by looking, because now I can see through the raster and I can see how things are looking in terms of lining up. And my control points now, I have part of that X-type pattern. So from the northeast corner to the southwest corner. And now I want to work from the south, I should say the, what would that be? That would be what? That's the southeast corner, I suppose, up to the northwest corner. So let's start over here in the right down in here, see if we can find some control points. So things have changed here, obviously. We still have, and I can always turn my shell map on and off. So North River Road used to be called Russell Road. We do see we have Prindeville Street is still there where it meets north, and that would be Russell. So we can see where that is. We can also see where Queen Mary is, Glen Avenue, and that road as well. So we have a few here. We want to get something as close to the corner as possible, but once we get over here, we now have a parkway that didn't exist back then. So we can't really use that region over here. So I'm just going to zoom in a bit over here, let's say to Prince Albert and North River Road, which used to be called Russell Road. And I'll click back on still on my appearance, and I'll just put the flipping now on and off so I can see where I'm going. So I'm going to look for here on the map, so right there where Prince Albert intersects Russell, and move it right up to here on the real world. So I click back on my Georeference, add control points, and right here is the intersection, so I'll click there, and that should be right up about here. There we go. So that fits better now. So again, I go back to my map tab, click on Explore, and I'll zoom back out. And maybe also turn off the flashing for now as well, just as I move things around here. So let's get something just in this area down here near the University of Ottawa. So King Edward and there's Somerset and King Edward. So that could use a bit, you could get a control point right there. And that's pretty easy to see. I don't even have to turn on the flickering. So I click on Georeference, add control points. And that's about the middle of the map or raster intersection. And that should be right here. There we go. And it moves it a bit. It doesn't move it all the way or anything. Because again, this is a transformation or affine transformation that's taking place, but a statistical one. So it's a first degree polynomial equation that's happening here. So I zoom back out a bit, click on my map, click on Explore. So now we have something there. And again, we're trying to work up this way. It's a little off the X, but that's all right. So we want something up here, maybe near the Parliament. So I'll just zoom in there. It's kind of a little hard to see things because there's a lot of different color transitions here in terms of contrast. So I'm going to go back to my appearance, and I can also use the swipe just to check things out. I could say, okay, let's have a look there. There's Elgin and Wellington. And on here, on the raster, it's a little bit off, isn't it? So there's Elgin right here and Wellington, but it should be up a bit more. So I'm going to turn on my flickering here. So the intersection of Wellington and Elgin is off a little bit. So I'll go back to my Georeference tab, add control points. And the intersection is right about there. And it should be just right about here in the real world. There we go. So we get another slight adjustment. So clicking back on map or appearance, turn off the flickering while I move things around. And then map, explore. We'll just have, again, an overall global look at our control points. So we have some there. And then we're kind of going up here. We need to get into Gatineau now. There's been quite a few changes here in terms of names of streets, as well as probably the size of the streets and whatnot. So, for example, Saint Jean-Baptiste Street is now called Elizabeth Bruyère Street. So you may not find the exact same names. Let's maybe look a little bit over here. So right here is Laurier. That hasn't changed. So let's look for some intersections of Laurier with some other things. And maybe I'll just turn off my map for a second. So I'm just doing a manual flash on and off here by turning it on and off in the table of contents. I think perhaps up here, Verdun. Yes, Verdun and some of the other streets there. So for example, here is Verdun and Champlain. And that's on our map right here, and that's where it should be right there. So that's a good control point. So clicking back on Georeference, add control points, find the intersection here, and then where it is in the real world right there. And I'll click back on map again, explore, and I'll zoom back out. So we have that X pattern now. It's not a perfect X, and that's because of this corner over here, so maybe we should look up in this region for one more here as well. So we'll check that out. Generally, you'd want to have 20 good control points in order to really assess the root mean squared error. I'm not going to do it in this example just because it would take too long. So I'm going to look over here. We can see Albert Street, for example, and the streets that are going off of that, they're not too badly off. So I'm going to just go up here. That's Slater. So that's changed a lot since 56. Bronson, Slater, and Percy should still be around, I think. No, that's gone. So that was changed. Albert and Bay, that looks good. Albert and Bay right there. So if I just zoom in, I can see that on our non-georeferenced map, the point is here, and it should be over here. So I'm going to turn on my flashing again, just to be able to get a good georeference here. Click back on my georeferencing tab, add control points, and here's the center of the intersection on the raster, and then over here too, where it is on our reference map. There we go. Click back on map, click explore, just so I can zoom in and out, and turn off that flashing, let's say. Or I can just leave it on now to kind of assess the overall appearance. So I can see in this region here, there's certainly some issues with alignment. For example, the street here, Bank Street, and this intersection here with Somerset West, for example. So maybe I'll put another control point there, just one more for this demonstration. Georeference, add control point. Here it is on the raster, the center of the intersection, and it should be over here. And that moves it a little. Click back on map, explore. I'm just going to zoom out a bit here to have one final overall look at the distribution of my control points. And I can also look now at my control point table. And again, that's, if you didn't have that open, georeferencing tab, control point table, and that will open that up. And I have right now 10 control points. And my RMSE is 15 meters. So what that means is that the consistency of the control points, in other words, the relations between X and Y, and X in the real world and X and Y from the raster to Y in the real world, are not one-to-one. So we have uncertainty here. So we have some imprecision in the transformation. So the way we can deal with that is with the residual error, we can sort it. So in the final residual here, we can have a look at the sorting of that. So the biggest residual is the last one I put on. And I can try turning it off and then watch my RMSE up here to see how it changes, as well as watch how my map changes. So I'm going to probably right now stop the flashing of the map before I do that. So it's not flashing now. And I'm going to maybe zoom in just a little so I can kind of see a bit better how things might modify if I turn off the one with the largest residual error. And that brings we don't see much change. You can see a small, very minor shift in things by turning that off. And then the next one is 8. So if I click on that, that's the one up here. I need that one up there. That's a very important one. So let's have a look at the locations of 6 is down there. What if I turn 6 off? What happens? Doesn't change the residual error much. One with that one in the center there, 15. What if I turn that off? Again, doesn't change the error much. And I'm just watching these numbers up here right now, as well as the map. So subsequently, I'll look at the next one. It was over there. I turn that off. Not a big deal. Not a big difference. Next one. Turn that off. Not a big difference. So I'm just subsequently going through each one, turning it on and off to see what the effect is on the overall RMSE. Because once you turn one off, the RMSE changes, as does the residual errors of each of the points that are still on. So that doesn't make a difference. No big difference. No big difference. Actually makes it much worse, turning that one off. So the only one that made a big difference was 10. Turning off the 10th point brought it from 15 down to 13. And then if I sort with residual error again, I'll turn off the 8th one. And that brings it down to 11. The 4th control point now has the second biggest residual error, or the largest one of the ones that are left on. So I turn that off. I have an error down to 8 now. And if I turn off the next one, the next largest residual error is here now. It's with 6. Brings it down to 7 from 8. And I'll just sort my residuals again. And then the 7th is 11. Brings it down to 5 meters. So with just these 1, 2, 3, 4, 5, we have a 5 meter residual error. And if I again sort by my residuals, now the next largest is, so I'll just do it in the same order like that, is 0.1 with 7. So we turn that off, we go down to 2. But that doesn't really mean too much because we only have 4 points on. That's basically an affine transformation with 1 extra point. If we zoom in, we'll still probably see issues with the alignment, perhaps. So we're seeing the alignment issues in this region. How about up in Gatineau? How's alignment there when we turn off those? So things aren't too bad there right now. Once we get up here, though, they're quite a bit different. So I'm going to start turning some of those back on, like 10, for example. That brings it way up too far. So now I'm going to subsequently turning on and off the ones I turned on before to see if adding any of them don't make too much of an error increase. So adding that first one back in is pretty good. And so here I have a forward of 5 meters. And so again, I would want to have 20 control points in here if possible to assess that, to say that that's a real 5 meter imprecision or error. But I'll just leave it at this as for the example. So I'm using 5 out of the 10 control points for my first order polynomial affine transformation. And I have a 5 meter error, or a 3.5 pixel error, 3.5 pixel error in the inverse. So giving that here, I'm ready to rectify. So I click back on my Georeferencing tab. I go to Save as New. And it brings up the Save as New Export Raster dialog. And so the first thing I have to do is choose where I want to save this new map. And I'll save it into my default geodatabase. I'll call it shellmap.tif. Click save. I already have one in there. That's fine. Overwrite it. The coordinate system output. Everything else here you can keep as default. And you click export. And that creates and overlays a new raster on top of this space and transfers the values of the old raster to the new raster that we see here. So if I zoom in close on this new raster, you'll see that the cells are cardinally oriented. If I turn that off to the old raster, and I'm just going to make it 100% the old raster shell map back to completely opaque as well. Look at so that's the georeferenced raster, which has non-orthogonal cells. And once it's been rectified, the cells look like that. And in this case, the nearest neighbor is being used to transfer the values. So there's no choice in this rectification. Oh, under settings, perhaps there is, yeah. So resample is nearest neighbor. And that's fine because it's a categorical map. So in the export general settings, you could change it to bilinear if you're working with generally data which is continuous, or even better for visual purposes, which is the purpose of this map, would be cubic. So I'm going to change it to cubic now, export again. So we're just exporting that using a bicubic resampling. And that's going to smooth things out and make things look a little nicer in the output, which is just for the purpose of visualization. So that's the bicubic one. That's the nearest neighbor. So look, so the bicubic shows much smoother transitions between colors than does the nearest neighbor resampling during rectification. And again, this is only because I only use bicubic here because I'm only interested in using this map to trace things so I can do comparisons with previous years. So look at there, again, that's the nearest neighbor rectification, resampling, and now the bicubic. And it's much smoother and makes text and everything look sharper. And that's why that's preferred usage of that for doing basic types of things like these. And I'll turn off my original shell map. And that one there. And now I just have left my, oops, there we go, just my, what we call a geo-rectified image at this point. So geo-referenced and rectified, geo-rectified, we could say. And all the no data area is in black on this. And I'd have to turn that off through appearance, symbology, RGB. And I'll say, no data, no color, and 000 as no color. It should show the black. What is the color? What's the value of black is 000. Generally, that should say a display background value. There we go. So now I just turned off the rest of it so we can't see it. And now I have this map which I could go in and do things with, like digitize features, so that I could then look at changes of things or look at building historical maps that are more digitally enhanced, for example, or anything. So that's georeferencing. Yes, it's a long process. It's a lot of trial and error and checking your points and sometimes turning some off, not using them, and things like that.